All right, I think we're going to get started. Thank you for joining this next panel discussion on building and deploying machine learning at scale. We're going to talk a bit about organizing ML pipelines from research to deployment. We're going to discuss pitfalls and challenges in scaling up our machine learning and analytics functions within our organizations. And we're going to also talk about navigating the best way to organize the business to become a machine learning focused organization. Joining me here today, we have three panelists. We have Ed Mitby from Vanguard, Rani Piputri from NN Investment Partners, and Tom Taylor from Man and Numeric. And I'm going to give them an opportunity here to introduce themselves. Ed, do you want to get started? Ed,
sorry, is that me?
Yeah, do you want to introduce yourself, please?
Yeah, no problem. Hi, everyone. Glad to be back. I'm a senior AI researcher at Vanguard. My current function has been mainly experimenting with alpha models using AI and ML for both rates and equities, mainly in factor modeling. I've also been vetting some ESG data sources, and also lately I've been doing quite a bit of work on the new term XAI, explainable AI, mainly around Shapley values, which I think is pretty interesting. Simultaneously, along with all of that, I'm kind of tasked with being a guinea pig for various infrastructure projects, initiatives surrounding AWS, SageMaker Studio, various analytics services, cloud storage, environment creation, that type of thing. So I've got the opportunity to do things from both a research standpoint and an infrastructure standpoint. So happy to be here and looking forward to the conversation.
It's great to have you here, Ed. I'm going to pass the word over to Rani.
Hi, everyone. My name is Rani Piputri. I work with NN Investment Partner, heading the adaptive investing team. We are an asset management company based in the Netherlands. We are affiliated with an insurance company and managing 600 billion of assets across different asset classes. My team manages the more systematic strategies, but my involvement with ML and AI is actually more on the firm-wide effort that we would like to pursue within NNIP to make the organization more ML aware and ML focused. So yeah, I've been a quant as long as I can remember. 20 years, more than 20 years ago I started, and now at NNIP, where we don't necessarily manage everything, all strategies quantitatively, but that is also an area that we like to explore, because obviously ML and AI is not only for the quants. There are a lot of applications out there, especially also for fundamental equities and in areas where data is still, how do you call it? Cannot be taken as given, such as the ESG data, as Ed mentioned earlier. So yeah, I'm happy to be here, and I hope I can complement the conversation here among all you guys who are, probably have put your hands very deep into this AI ML pool on all technicalities. Happy to be here.
That's great, Ron. It's great to have you. Tom?
Yeah, that's great. Well, hello, and very happy to be here with everyone today. I'm Tom Taylor. I work within the Alpha Technology Group at Man Investments. I am currently the head of Alpha Technology for Man Numeric. So we're an asset manager based here in Boston, Massachusetts. We're primarily a quantitative asset manager, trade equities and fixed income and various other asset classes. Been at Man Group for about 11 years. I'm sort of an engineer by trade, so my focus is much more on the sort of infrastructure side of things. Ultimately, in my current role, I look after all of the engineering needs for Man Numeric. That includes the sort of research platform. So sort of how our research and portfolio managers go about performing sort of equity research, be that sort of more fundamental based or machine learning. I also look after actually sort of running those quantitative models every day in a production environment that we can then trade off. And my team is also responsible for sort of working and really embedding in with the research team on particularly larger initiatives where we can bring our engineering skill set into those projects.
That's great. Thank you. Thank you, Tom. And again, thanks all of you who are still joining this. Looking at the attendee number going up, it's almost like day trading, right? You're happy as long as the number of attendees are keeping on increasing as opposed to decreasing when we need to start short selling here. Right, Ed? My name is Peter Kolm, and I'm a professor at NYU Courant. I've been at NYU for the last 14 years or so. I'm also very active in the industry, sitting on several advisory board of fintech and financial data science driven type of companies, Betterment, ISOT, AllTG. Also active in the research community, predominantly focusing today on how to lever cutting edge machine learning techniques to solve buy-side related problems, including that of signal generation, portfolio construction, risk models, and trading type of problems. I'm super excited to moderate here this panel because we have a number of different interesting aspects to cover and a lot of experience gathered in the room here today. So where I wanted to start off here is maybe again go around the room and let each one of the panelists talk about a recent use case that you have that involves building and deploying machine learning at scale, right? Talk a little bit about the business use case for this is, and maybe pinpoint a couple of challenges that you encountered. And Tom, if I can start with you.
Yeah, sure. So I'd say, coming from my engineering background, the most sort of experience I've actually had here is around that scaling part. And how do we take, let's say, alpha research that uses machine learning and actually scale it up into something that we're actively doing on a sort of day-to-day basis as part of portfolios. I think that experience has probably lasted a number of years now, and I think if you look back at what I've witnessed is that probably around 6 or 7 years ago now, you may have had a small handful of researchers doing sort of machine learning on the side, maybe hitting against some infrastructure and data bottlenecks. And really the scaling in my experience has been, how do we industrialize that process and actually democratize machine learning so that other people in the organization can actually use some of these newer techniques. And let's say if you've got an expert in something like fixed income, how can they use their expertise in fixed income with some machine learning techniques such as natural language processing to actually pull insights that's then valuable to them? So slightly moving away from, having everyone be a machine learning expert who does machine learning. In my experience in that sort of scale up process, I think there's been 3 things that we've had to get right. I think they're number 1, infrastructure. I think a real part to the scale out is having a robust set of infrastructure and platforms that people can actually go about and perform their machine learning research on. I think the second component to that has been getting data right. I think data is a really hard problem. We're all drowning in data, but actually when it comes to using it in machine learning or any other application, particularly in a quantitative area, the key thing is understanding that data, how it's constructed, and particularly as we get to more automated processes for sort of generating research or sort of coming up with new ideas, I think understanding, the real finer details of data is really, really critical. What might happen if a security is suspended, or what might happen when a security is delisted. Making sure all of those sort of things are part of the metadata of that data set, I think is really key, so that you kind of spot mistakes early rather than later in that process. I think finally, sort of in my experience, the final pillar here to that scaling is teams. And I think it's really critical that you've got the right set of skills. And in my opinion, you've got the right culture to really scale up machine learning in your organization. You need to have both machine learning experts, plus perhaps the more financial experts, plus a team like mine, which is much more sort of infrastructure focused and technology focused, all really working together to make it possible to perform large-scale machine learning experiments, and hopefully, if we find value in them, be able to put them in an environment where we can actually trade off those insights off a daily basis. So that's primarily been my experience, and sort of the insights that I've learned is if you can get those three pillars right, the infrastructure, the data, and the teams and the skill sets, then that is how we've seen scale.
Yeah, that's great. That's great. We'll continue this in a little bit. I'd like Ed to elaborate a little bit here first on his use case, and then we're going to merge these different views together.
Yeah. So I've got an interesting perspective on this. I've done a couple of use cases lately from really two different angles. I can't really talk too much about what we've actually done internally, but I can talk generically about, alpha generation projects in both rates and equities at various horizons, because the setup is very similar. So the challenges end up being the same. And then in contrast to that, I recently wrote a white paper called Tactical ESG Trading Using Reinforcement Learning. And that was basically on my own platform, not a corporate platform. That was for a Stanford program. And so I got to use things in an environment where everything basically worked seamlessly, which is much different than most people's corporate environments. And then also right now, back to the data thing, and that's a continuous topic in machine learning. I'm also doing a project right now testing whether ESG ratings deltas translate into any kind of alpha at any level, at the sector level, at the granular ESG level, stuff like that. So yeah, I think the big takeaway is that and I've been doing quantum mental stuff for quite some time. I think that the big takeaway is almost none of what I just talked about would be possible without a GPU. And that requires ML infrastructure, right? So whether you're probably not going to want to get into, actual hardware, but, and so you want to start looking at, the cloud or AWS or something like that. But I think it's pretty amazing that you can accomplish these things that weren't really feasible to even run, not that long ago. I think one of the bigger challenges in doing, time series related work in financial data, and obviously a lot of financial pricing data is, it's quasi time series data, right? It kind of looks like a time series, but it's actually not, right? It violates probably every rule possible. And then you've got the signal to noise ratio and all this kind of stuff. I think your traditional machine learning model of a train test split or a train validation test split, where you can randomize it, say for image recognition, where you can take the data, randomize it, have a train test split, and just kind of train it on one set and test it on the rest. It really doesn't apply anymore when you're talking about time series, because really what you're doing is, I think two typical ways to handle a time series would be either an expanding window or a sliding window. And, at every step, you're basically changing your training set and your test set. So now the compute required is not just running one model for like some image, data set. You could be running hundreds of models if your horizon is daily or even a month, right? Depending on how long it goes. So what happens is that the compute basically becomes exponentially more expensive and longer. And so that's something that, and there, that's just one of the idiosyncrasies of trying to do, financial time series data. The modeling required involves potentially hundreds of models just to do a simple series from year 2000 to 2017, right? It's just not a matter of randomizing it and taking, 2000, 2012, and then I'm going to test on the next 5 years. Another challenge that comes along with that is explainability, right? Explainability is a big topic right now for any model. And now you could be running 200 different models to get your aggregate kind of RMSE at the end. That's kind of an issue. Another challenge is what model do you use? I mean, different algorithms do different things, better or worse, right? XGBoost is probably one of the most effective algorithms developed, probably in the last 100 years for certain applications. But, tree-based models can't extrapolate. They can only interpolate. I was working on an interesting project involving treasury yields, and using XGBoost when rates started going to record lows in, Q1 2020, it couldn't, it was pegged out at 2% or something like that, because that's where the training sample is the lowest level. So it's interesting. So it never would have predicted the lowest levels ever. Same, the reverse side of the stock market's at an all-time highs. I doubt an XGBoost model would be able to, predict that. And so linear regression is great at projecting or extrapolating, right? So it's funny that the most advanced machine learning algorithms can't really do kind of project a value beyond what it's already seen. So I think you have to know the limitations, and and like data is going to be a continuing topic here, but comments on that. I'm vetting ESG data right now. I think no one will argue that it isn't a complete mess, right? You've seen MIT's aggregate confusion project. It's and you look at these ratings. I was just looking at, I won't say the name of the provider, just about an hour ago. And Apple has the same aggregate rating as Chevron, right? And it's like, you look at that and you're like, okay, I guess I kind of get that given the subcomponents, but overall, it's kind of hard for me to see why a tech company is the same as an oil driller, basically. And, on top of that, Amgen wasn't even working. So, it's, the data issues are there. But I think the good thing is that, a lot of this stuff wasn't possible that long ago. So it's pretty exciting to be working on this stuff. And, but there are challenges.
Thank you for that, Ed. Yeah, absolutely. And we'll get back to that in a few minutes. Rani?
Yeah, actually, a lot of things are already covered by Tom and Ed. And what I do want to add is that, I do want to mention one of the basic thing that we discovered a few years ago when we entered the journey into the machine learning focused organization is the mindset that machine learning means that, sometimes you get the outcome from a machine that learns from itself. And that means you cannot pre-impose necessarily what you want it to be. You get an outcome that you have difficulty understanding how it get to there. Sometimes you understand how the machine get to certain outcomes, but sometimes you can't. And so traditionally people, especially the fundamental PMs or analysts, they would easily dismiss that kind of thing. Said, oh yeah, the model is broken, the model is not good. But now with this kind of new technology and the possibilities that are available with all kind of data and AI techniques, we are actually ask ourselves, are we really serious about wanting to do this machine learning, artificial intelligence? Because that means that we also have to be humble about our own conception about certain things. So once we get that set, that okay, we cannot assume that we are the ones who always know everything and that we know the only path to a certain outcome, then it's easier to scale this kind of ML efforts through the whole business basically. And some of you are probably not aware, but NNIP is not necessarily a quant house. So we do all kind of things, and in general, we have many fundamental PMs and analysts, and actually having the data scientists, having the technology people embedded in those investment teams, that changed the culture and that brings the real change. And as for the project that we've been doing, part of having an open mindset is that we also have to allow our people to experiment, that we try certain things and maybe the outcome is not necessarily what we want to see, but some of the projects that we did as part of our experimental effort is on the wisdom of the crowds or madness of the crowds, depending on what context you're looking at. So we look at the data from multiple sources, not necessarily from the financial professional in our own firm, but also outside of the firm. This is actually inspired by the work of Tetlock. Some of you probably are aware of it, that, about super forecasters. There are people out there who can make more accurate forecasts than others. And we try to see whether that also applies in financial markets. So we look at publications, we look at Twitters, we look at all kind of media outlets to be able to find such super forecasters. And fast forward a couple of years later, a lot of things we learn, and we end up with an alpha model that not necessarily, it didn't give us the exact financial super forecaster that we follow and that will give us the suggestion of stocks to buy or to sell, but we did get some alpha out of this whole process. Just like some kind of medical research, you search for something, and then at the end, the drugs that you found is actually more potent for other diseases. So that's one of the projects that we've been running. And another thing that we're doing right now is some form of artificial stock markets, because financial data is very limited compared to the abundance of data that people use in face recognition or other things where AI is being used. So we're trying to find, to create an environment where we can test how certain agents within that environment will interact with one another, because traditionally, if you look at some kind of factor investing, you have a certain role, you do certain things, and you expect certain outcome. But what that kind of strategy often assumes or ignore to recognize is that whatever you do will affect other investors, will affect the market. So there is this loop, this interaction that is not really captured there. So that's something that we would like to also understand a bit more. So if we, for example, if a certain style becomes very popular, becomes crowded, what can we anticipate out of that? What kind of investors would move first or later, depending on their process? So it's a very complex project, and hence the name of the team is also Adaptive Investing Team, because we live in an adaptive system. So whatever we do will affect others and vice versa. So that kind of interaction is something that we would like to incorporate. And new techniques in machine learning is excellent to be able to do this.
Yeah, thank you for that. I mean, what I'm hearing from all three of you here is that this is new technology that we're rolling in. Sure, some of these machine learning algorithms have go fairly far back, right? The neural networks from the 1950s, so on and so forth. But it's not until now that this has started to be deployed at larger scale within the financial industry. One of the things I'm curious, Rani, based on what you were sharing with us here, is this leads to a number of not just technical challenging issues that all of you alluded to, but also, how to put together the teams. This is a multidisciplinary type of approach. Can you maybe hit upon a couple of points here, what you have found being really important when you're putting together these multidisciplinary teams? How do you balance this in terms of data scientists, mathematicians, computer scientists, so on and so forth?
Yeah, so that is also something that we change in terms of our structure, because previously we had a centralized research department. All the engineers or the mathematicians, they sit in one group and they do all kind of marvelous research. But when it comes to implementation, about how do you actually translate that into a real life portfolio with all kind of messy things that happens in the market at that moment, it's that translation doesn't happen very effectively. And sometimes we even had discussions when we measure performance. A researcher would say, well, I'm entitled to my bonus because look, my models perform this and this much. But the portfolio managers who use that model into real life, they don't get that kind of performance, and they will say, well, it's not my fault, the model sucks, and that's not a realistic model. So that kind of situation happened. So now what we, a few years ago, we decided to have this investment team to be more holistic, to more inclusive. So we have people from technology, people without financial knowledge into the team. We get an AI specialist into the team. have them sit with the PM, have them sit with fundamental analysts, and have this conversation. And it was quite interesting at the beginning, because you put all these people together and it's as if they speak different languages, but it takes just a little time, because at the end they all have the same passion. They love to discover, they love to generate alpha, they love to get good performance. So that commonality brings them together, and it's an education process for each one of them to understand, when someone starts talking about boosting, a PM from 30 years ago, they also have to learn what that means and what the implication is in terms of the choices for the portfolio. So, but it's been very rewarding, because you see the composition of the team also, it's more diverse, you see people from different age, from sometimes different background, and it is, it's not without its challenges, obviously, but it's great to be part of that.
That's great. Yeah, thank you for sharing. And you, Tom, you worked a lot on building large ML platforms and scaling them up and so forth. Can you share some of your learning experiences here, and the challenges and how to go about them?
Yeah, sure. And it's interesting what Rani said about that translation from the research process to perhaps the production or the trading process. It's something that I think you really have to optimize. I mean, I'd say the worst word as someone who leads an engineering team is to hear the word matching, where the research team's kind of developed something, the technology team's gone away and developed something with a different code base, and now you're trying to match. And then if you ever heard the word matching, in my mind, I mean, something's gone wrong. So I think in my experience, what really leads to success, so that you avoid that kind of issue, is having a single platform that people are working on. And by platform, it can mean many different things depending on your team size. It could be a wiki page that says, if you're going to do machine learning research, here's the various packages that you should install into your environment, and here's the versions that we're all using. It could be as simple as that. In a perhaps larger organization, it's perhaps you download the actual machine learning package, and the machine learning package is kind of wrapping under the hood all of the nuts and bolts and the sort of glue code to take data, run it through machine learning, and actually give you the results. So I think the key thing in my mind, number one, is that platform, but it can take many guises and be different things depending on your organization and your scale. I think secondly, when we do have these projects, getting technology involved early, I think it really helps if they're there, the project kickoff, they understand what the goals of this particular piece of research is. They can discuss, and we can between the machine learning researcher and say technologist and maybe an investment expert, we can all sit down and discuss and think of what are the sort of problems that may come up in the future. And it's a good time to ask questions such as, hey, in research I realize you're using 8 GPUs. In production, if we're running this model on a daily basis, like what sort of resource do you need? Is it CPU? Is it GPU? How much? Getting those sort of questions answered really early on, I think, in that sort of process is a very useful thing and stops that sort of long tail that you might see. I think as well as the sort of single platform, having a single code base here really helps. As long as the platform is, we call it internal open source. So, anyone can go there, anyone can check it out, anyone can understand, how data is flowing through this platform, I think is really key. And to make sure that, any research that's happening, again, is all sort of internal open source. You can jump into it, you can understand what's going on, and it's all written against, that single platform. I think the final part I think I've seen to really scale this is to, particularly in the finance world, try and push as many of the sort of edge cases that you might see in the real world, further down that research process. So for example, if security is suspended, that should be a first-class concern in your sort of platform. There should be an easy way to tell if security is suspended, and that should just be part of how your research is sort of happening, and it takes into account those sort of things. Because the worst thing is, you get to the end, you've got this single code base and it's all built on the single platform, but actually you can't, you can't interpret the results on any day, because it turns out those sort of 5% of edge cases are really skewing things at the end. So for me, I think if you can get those things right, you can have a robust infrastructure with a platform, whatever that means for your scale. It can really streamline both the research process and then, if it's successful, getting it into something like an actual quant portfolio.
Thank you, Tom. And Ed, what about your end? What sorts of, shall we call it, growing pains have you experienced here in this regard? And maybe you can also share what can happen when things don't go according to plan.
Yeah, I think I think that once you move to a cloud-based system, as opposed to like a local stable environment, there are so many moving parts that it can be difficult to keep everything working. So if you're using AWS and you're trying to use SageMaker, and anyone who's logged into the SageMaker console, there's a million different services you can use on your personal account, right? And now, and back to AI explainability, they're building almost an entire service around explainability called Clarify right now. They're building that out pretty aggressively. So it's something that's there. There's a lot of moving parts, right? So integration with corporate security, proxy tunnels, databases, etc., can be hard. Standalone, all this stuff is easy. Like anyone can go home with their AWS, Prime account, open up SageMaker, build a database, and start using a model, right? I mean, that's not that hard. Once you start involving corporate kind of infrastructure, then you can run into problems. And along with that, something that I think kind of goes with the territory in terms of machine learning is all these packages are moving incredibly fast, right? It's not like, Windows 7 to Windows 10, and it kind of takes 10 years for people to migrate, right? TensorFlow comes out with a new version, every couple of weeks or something like that. And getting all this stuff to work together is hard, regardless of whether you're in the cloud or not. A great example of that, I think, recently, back to AI explainability, which, AWS is building their platform around Shapley values, and the library I think everyone's using now is called SHAP. It's a pretty interesting package, but it is open source. I think it's maintained by one guy. I think AWS is probably going to migrate it to their own version of SHAP, but, he's doing a great job and I have a lot of respect for him. But, now there are problems using SHAP with TensorFlow version, 2.3 and up, right? The deep learning version doesn't really work, and the charts don't work, and all this stuff. So you're constantly dealing with compatibility issues. And that's just something that kind of, I think, goes with machine learning, with a fast-paced kind of technology, and things are always changing. It's reinforcement learning is the same thing. There are a ton of libraries out there specifically for reinforcement learning. There are a ton of papers involving reinforcement learning for financial markets and that type of thing. Replicating any of that is, I've found, pretty difficult, right? So the compatibility plus the infrastructure needs can be pretty challenging. And then to run all this stuff to begin with, you have to have the data. And again, this is a recurring theme, and I'm not going to beat a dead horse, but depending on your organization, one thing I've seen is a big problem is people who think they have data when they actually don't, right? So the vast majority of people out there using a Bloomberg, it turns out that's not really going to be usable for a machine learning project, because the contractual kind of constraints on Bloomberg data in general are pretty, make it basically unusable depending on your contract, but also it's very expensive, right? You're not going to go download a bunch of historical data every day using a machine learning project. So you might be going to someone, an end user with some kind of use case, and they're like, look, I have all this data on rates and macro data and all this stuff. And it's like, well, actually you don't, right? You may see it, but it's unusable from a practical perspective. And data ingestion is a big topic. And like Tom said, it's hard. And like I'm looking at ESG data now, it's the Wild West, basically, right? And then you layer on top of that contracts and cleaning and scrubbing and, what's your budget to look at this? Do you have people who can actually vet all these data sets? And so it's, the process itself is definitely going to involve growing pains for most people, but, it's something that's just the way it is. And, hopefully most people out there who go down this route, you can find people who can do this type of thing. But, it's definitely a dynamic industry, a lot of moving parts, and there are challenges, but, that's just something I think most people need to be aware of as they kind of venture into this type of thing.
Thank you, Ed. We're going to turn to participant questions here in a couple of minutes. So I encourage all of you attendees to please post your questions to the chat. I know we have a number of people also participating here on this call here today that work for organizations that maybe have not gone in this direction just yet, right? Currently not deploying machine learning and data science in their organizations. So, Rani, what advice would you give to these people and their companies? Where do you start if you're going to go down this route? Where do you start?
Where do you start? That's after listening to what the other panelists said, there's a lot of challenges down the road. So I think the first part is to have a real commitment and to actually have this idea of machine learning focused organization to be supported and further pushed by the management. This is very hard when you are a data scientist and you have you are passionate about certain things and you want to do it, but if you cannot get the whole thing running, you cannot, it's very hard to get it sustainably, because all the issues that I mentioned earlier, we need to be able to maintain all those systems, the compatibility, the data, and this is not how do you call it? It is not something that just sits still for the next 6 months. So you do need your army there. So it's not that it's that only very few people can do it. People can do it because people can learn. It's just that you do need to have that commitment. So where do you start? Well, you have to be sure that you're ready for it, and this is not a hobby. This is something that you have to do it when you actually are passionate about it, and you can convince a bigger the firm to actually embrace it.
No, thank you, Tom. I related to this, a question from an attendee here is, so how do you switch from legacy methods, right, to a platform like the one that we've been talking about without anyone getting wounded in the process?
Yeah, it's actually a great question, and I'll say my background actually based here in Boston, Massachusetts, as I mentioned at the start. Actually the first reason why when I joined Numeric, first project that we were undertaking as an organization was one of these big platform shifts. We had historically been on SaaS, which is I think a leading technology within its time, and we were gradually translating that over to Python. It's really quite a hard challenge, I'd say, but if you can get it right, it can lead to a huge sort of real competitive advantage for the organization. In our instance, actually, if you go to the Man Institute in the tech articles, we actually wrote a little document in there about sort of how we undertook that process. I'd say the key thing around doing one of these big platform refits or revamps is to get buy-in from the business. If the business is brought in and they understand that sort of the value that it's going to bring and the agility it will bring, from then on in, as long as there's both kind of bottom up and sort of top down buy-in, there will be issues that you hit along the way, but actually navigating them at those times will be much simpler than if you hadn't kind of gone into this with everyone's agreement going in. I think the second thing I'd say is that be prepared, particularly within a speciality, to become a generalist, because as you go through this platform sort of reorg or kind of re-platforming exercise, your job will not just be the sort of technologist or the researcher. It's going to be the person who's kind of holding the client's hands. It's going to be the trainer. It's going to be the salesperson. And you really do kind of have to take on all of these different hats if you're leading one of these projects. I think finally, I'd say if you do get feedback that the platform you're building isn't meeting all the use cases, really take them seriously, sit down and listen to people and really try and understand what they're trying to achieve and why the old platform, perhaps did something differently or better than the new platform. And if you can kind of just solve those things as they come in, every day someone's going to come to you and say, this doesn't work as well in this new platform. But if you can solve those things as you go, you just build up that momentum. But yeah, great question. It's a tough challenge, particularly with a large scale replatforming effort, but you'll really reap the benefits and costs, really reap the benefits, particularly when it comes to sort of agility and staying on the bleeding edge of innovation.
And Ed, this obviously also relates to the corporate culture within the company. And one of the attendees here is asking about that. What are the issues here that one may encounter in terms of the corporate culture with respect to now rolling in a completely new, potentially new infrastructure way of thinking about problems, so on and so forth. What do you see from your perspective in terms of the corporate culture in this regard?
I think it's a very interesting question. And you could even raise it up from within a firm to like almost this massive divide in the way AI/ML is viewed from, say, tech firms versus financial services firms. If Google, I've used this example 1,000 times, if Google stopped using AI tomorrow, they would go out of business almost immediately, right? I mean, everything they do is based on AI models. If Warren Buffett stopped using AI tomorrow, he doesn't use it to begin with, right? So it doesn't matter. So the financial industry is much different than many other industries, meaning you can be a completely discretionary person and do perfectly well, right? I believe in quandamentals. I think you do need some kind of system, some analysis and modeling and that type of thing, but people have done perfectly well in, fund management without using any kind of quantitative systems. So it's a much different industry where you might not have a choice, right? Again, Amazon is not possible without recommendation systems and machine learning, right? So within firms, I think it depends on the firm. Clearly there are some quantitative focused firms out there that are much better at data ingestion. They're much better at modeling. They have people who can code and that type of thing. And then on the flip side, you have firms that everyone's kind of a fundamental person, probably not a lot of technical backgrounds and that type of thing. So it depends on the firm, and I think so back to the ESG thing. I think ESG has really kind of brought this whole thing into focus, because a lot of fundamental portfolio managers or analysts out there are all of a sudden faced with kind of this ESG phenomena where, you need to do even a basic kind of exclusionary screen. You need some kind of data source, and you need to be doing some kind of screening, right? And that's I think it's a different animal for a lot of these people. So it's almost, if you believe in the screening, which a lot of people do at this point, and I think it's gaining traction, people who weren't doing this kind of thing before are almost going to be forced to do it. Because, the color we're getting is that institutions and, limiteds are coming to funds saying, where's my screen? I don't want these stocks in my portfolio. What are you doing? You got to get rid of these. I think before there was kind of a schism between, the deep fundamental analysts, and I was a deep fundamental analyst for several years, right? And versus more the quantitative approach. But I think it's interesting that the ESG thing alone is kind of bringing these together almost by necessity. So I think whatever cultural clashes there were before, I think that, they're going to have to be resolved one way or another at this point. Because, personally, I think ESG is going to be a big driver of financial markets for the foreseeable future. right? And, the ratings are not omnipotent, but, I think you do have to pay attention to them, and they're helpful, and you need to know what you're doing, right? So it's an interesting time in that, yes, they're having culture clashes, but, I would say ESG alone is kind of forcing people to, figure out how to get around those at this point. And that's kind of what I'm hearing, and it makes sense. So I think it's an interesting time to kind of see this dynamic happening.
Absolutely. Yeah, I couldn't agree more. We talked a bit about models. We talked a little bit about data. And one of the points that I wanted to make, and then also ask a question that comes from the attendees, is the point that we shouldn't be looking at data and models in separation, right? Models and data go hand in hand. The models, the data is actually part of the overall model. So if we have crappy data, our overall model framework is not really going to work. With the accessibility now of a tremendous amount of data, right? And I'm going to expand this now also to think a little bit and ask the panel about alternative data sources that's been very popular here in the five last years or so. From your experience, have you seen machine learning specifically being effective in terms of integrating alternative data sources in these types of frameworks, and thereby better driving the investment processes? And if so, what are your thoughts about measuring or quantifying the effect of the alpha that comes from these alternative data sources? Who would like to go first on that? Maybe Rani, do you want to address it first?
Yeah, I was thinking about the question as also what Ed mentioned earlier about the ESG data, because one of the use case, at least in my firm, is there's the different techniques of machine learning and AI to fill in those gaps in ESG data, because I don't know, Ed, you probably have the same or different experience with different kind of data providers on ESG. They tend to be quite specific in certain areas. So you have a data provider gives you all kind related to carbon footprints, but it doesn't really tell you about how they treat their workers or how their labor relationship is with their employees. So in order to integrate multiple sources with different kind of structure, with different kind of interpretation, sometimes you have to find a route. So we use certain techniques, some kind of impunet to be able to predict what would be the missing data be, based on this big data. And yeah, obviously it is, we don't use it blindly as, okay, so this is what machine learning tells us what the social score is of this company. It is still have to be fed by the investment team, because at the end of the day, we still have to talk about this to our clients, and our clients need to know what's really happening. We cannot just say, oh, yeah, we aggregate all kind of things and then this comes out. So that wouldn't work. So yeah, it is definitely helpful, especially in terms of data analysis. In the first phase, we can spot data issues very quickly, but it is not, how do you call it? It is not one automated button that we can press and then it will tell us, okay, this data is good, this data is not good. So it all depends on the context. What kind of data are you looking for? Is this low latency or a high latency? Do you want to use it to make tactical asset allocation, or do you want to use it to pick stock? So it is, in my experience, at least, it's a bit more complicated job, but that's where the AI is actually being used for us to help fed the data, alternative data, much better or quicker.
Thank you, Rani, and we're nearing the end here of the panel, but I wanted to see, Tom, if you had a couple of comments in regards to alternative data and your experience here, whether it's useful in terms of leveraging your investment processes. And
yeah, it's a good question. I'll kick off by saying I don't like the word alternative data, because it might be just data. But yeah, of course. I mean, I think in my experience, if you look at the history of sort of alternative data coming up, it mirrors the history of sort of machine learning being used more and more in financial markets. And yeah, of course, there's applications of machine learning on alternative data sets. I think particularly exciting is things like text. Text is one of those areas where really you do need machine learning to be able to give you your sentiment score, or really dig in. And there's so much text that is available to us on the web, in our emails, from transcripts, or from Edgar. Investing in things like having an easy way to process text and answer the question, okay, these 5 broker reports just got emailed to me, is it good or bad news? Having that, I think, is going to be capabilities that people will continue to look into going forwards.
Thank you. And with that, I'm going to thank the panel here for a very interesting conversation on building and deploying machine learning at scale today. I want to thank you, Ed, you, Rani, and you, Tom, for spending some time here today, and also thank all of you who attended. See you at some of the upcoming seminars and panels this afternoon.